Here we're going to find the volume of a solid of revolution, and the region is the same as we've had in the last two examples, but this time we are going to rotate it about x equal 2. So let's go ahead and mark where our axis of revolution is. That would be right here. And so as we rotate this around, you can see that we would have this cone looking thing here as we rotate it around x equal 2. So as we make a representative slice here, we can see that it looks like this, and we know when we're doing washer method that the representative slice will always run perpendicular to the axis of revolution. So there it is, and so I can see it's a little thickness in the y direction. It's a little dy. And so everything's going to be in terms of y. Our limits of integration, we are going to run from y equal 1 then up here to y equal 2, so from 1 to 2. And so we're going to have pi. Now as we see this, we will not have a washer because there's no hole in the middle. We're rotating about this edge right here, so we will just need a disk. So I need to figure out what this r is. Now I'm actually going to draw this a little bit bigger so we can look at it and see what's going on. So we have this triangular region, and this is right here at 2. And as we look at that, this comes over here for this axis, so let's just kind of put those on there so we can see. But as we make this representative slice to see what our r is, it's not the value here, and in fact if we looked at the x value of this line right here, that would be this piece right here that we don't want. Let's look at it in one other place. If we looked at it here, then if we found the function value right there, that is this distance right here. So what we can do to find the r at various slices would be to take this distance 2 and subtract off this x value right here, and that would leave us the r that we need. And so we are going to again want x as a function of y, and that was 2y minus 2. So to express this radius, it's going to be 2 minus this x right here. So that's going to be 2 minus, well, the x right there is 2y minus 2. So 2y minus 2. And that is the radius of this, so we need to have that squared. So that's all because there's no hole, so it's just a disk. So let's move the pi out in front, and then let's see what we can do to simplify this. So this will distribute and make negative 2y plus 4 when you combine that here. So negative 2y plus 4, and then that needs to be squared. So it looks like we're going to have 4y squared. We still have the integral from 1 to 2. And if we multiply these together, negative 8y, and there's two of those, so negative 16y, and multiplying the last plus 16, and our little dy. So now we're ready to integrate. So we have pi. Integrating here, we have 4/3 y cubed minus 8y squared plus 16y, and we need to evaluate that from 1 to 2. So that leaves us pi. So that leaves us putting a 2 here. That's going to be 8 times 4 is 32 thirds minus putting that here as a 4 times 8 is 32. Putting it here plus 32. And then putting in the lower limit and subtracting it, we have minus 4/3. Putting it here and then subtracting will make that a plus, and then putting it here and subtracting will make that minus 16. So let's go ahead and see what we can do to simplify. It looks like these will cancel, and here I have 28/3 minus 8 would be 24/3. So it looks like I'm going to get 4/3 pi for my volume.